All right, what we're going to be talking about today is something called domain and range. You're going to see this all throughout math, the word domain and range. And on your notes, I say domain is your x values, in your range are your y values. So think of it on an xy coordinate plane. Let's take a coordinate of, let's say 2 and 1. Your domain is your x value. So your domain for this coordinate would be a simple 2. Your range are your y coordinates, or in this case, your single y coordinate. Your range is equal to 1. So whenever you have a coordinate or a set of coordinates, or anytime you're talking about an xy coordinate plane, think of your x is always your domain and your y is always your range. So on the example where I say -3, 4, 2, 8, on your notes, 0, 10, I gave you these 3 coordinates. And then the question is, what is the domain of these 3 coordinates? What is your domain, or your x values? So your domain would be -3, 2, and 0. You don't need to list it in any specific order either. What's your range of these coordinates? Your range is your y values, 4, 8, and 10. So your domain is always your x. Your range is always your y. You're going to see these two words all the time in math. Now, next thing it's going to ask is if a function has repeating x values. Oh, if you have a function and it has repeating x values, then it is not a function. So look at the first set of coordinates that I give you in your notes. I say, okay, let's take 4, 6, -3, 0, -100, 7, 4, -8. And the question is, would these coordinates create a function? The answer is no, because if you have any repeating x value, if an x value repeats just one time, it's not a function. See how there's a 4 here and a 4 here? You have the same x at least once. So this is not a function. Now look at the next example. We say -8, 7, 5, 7, 1, 7. Look, this is a function because even though the y values repeat, the x values do not repeat. The x values don't repeat. So yes, that it is a function. Now, what I'm going to do is I'm going to go one step further. I'm going to graph these 4 coordinates, and I'm going to draw an x, kind of like a line. So let's say 4 and 6 is here. Let's say -3 and 0 is here. Let's say -107 is, like, let's say here. And let's say 4 and -8 is, let's say right here. Oh wait, I'm going to say 4 and 6 is right here. Okay, look. If I were to draw like a line and create just some type of a function, this would be this function right here. Now, if I were to create an xy coordinate plane for these, -8 and 7, let's say 5 and 7, 1 and 7, this would be this graph, this would be this graph. Now, this is not a function because Notice how if the x value repeats just once, it's not considered a function. This is where the x value repeats. This is a function because even though the y values repeat, there's only one x value for every y value. So like let's say there's only one x value here at this point. There's only one x value here if you go up at this point. There's only one x value for every y value. There's something called a vertical line test. And this allows us to see if a graph is a function or not. If we can run a vertical line straight through any graph, and if it only hits one point at a time on the graph, it is a function. Watch, I'm going to run this pencil, which is a vertical line, through this red graph. It's only going to hit one point on the graph every single time, therefore it is a function, which also verifies with the data that it is a function. Let's run a vertical line through this and let's see if it hits the graph at any more than one point at a time. So if I'm running, and I still only hit it at one point, but right here, notice I hit it at least 2 points. The vertical line touches at least 2 points on the graph. This is not a function, which is verified here because it's not a function when the x values repeat. So you're going to have graphs. Let's take the examples that I give you. And I'm going to draw quadratic like this, and then quadratic like this. Is this a function? Well, let's run a vertical line. Let's run this pen through it. I only hit the graph at one point every single time. It never touches it at more than 1 point. This is a function. So you would answer yes. The reason why is because it passes the vertical line test, or there are no repeating x values. Is this a function? Let's run a vertical line through it. Notice right when I do it, boom, I actually run into an infinite amount of repeating x points. All it has to have is one set of repeating x points where it touches the graph at more than 1 point at any point of the graph. This is not a function. This is because this passes the vertical line test. This does not pass the vertical line test. Okay, now the other page of notes. When you have a graph, it's going to ask you, is something a function or not? It's also going to ask you what your domain and range is. So on your notes, let's take this. And if I were to ask you what's your domain and what's your range for this graph, your domain is your x values. So how many x values does this graph have? The answer is infinite. Or if that doesn't make sense to you at all, think of it like this. Think of it like this. Whenever it's asking for the domain, on the notes, I say, how far does it go left and right? How far does this graph go to the left? It goes to the left forever, and it goes to the right forever. It's technically diagonal, but it's still going to the right forever. Whenever the answer is it goes to the left and to the right forever, you say your domain is all real numbers. Meaning, any x value I can go down and hit the graph, or any x value over here I can go up and hit the graph. But the way that we say all real numbers is this. We do a symbol. It's like that. That's all real numbers. All real numbers, think of it as forever. Now, what is your range of this graph? Your range are your y values. Your y values go up and down. So on a graph, how far does it go up and down? This goes infinitely down. Yeah, it's going diagonally down, but it's going infinitely. This is going up infinitely. It's diagonal, but it's still going up infinitely. So your range, how far does this go up or down? The answer is forever. Well, we can't say forever. We would say all real numbers. So your domain is all real numbers and your range is all real numbers because it goes infinitely to the left and to the right and infinitely up and down. Let's look at the second example. Here's your graph. And the quadratic looks like it has a vertex of 3, -1. Or -2. Looks like it's -2. It's the vertex. What is the domain? Remember, come back up here. Your domain is how far it goes left and right. Well, let's look at this. It goes diagonally down to the right forever, and it's going to go diagonally down to the left forever. So what is your domain? Your domain is going to be all real numbers because it's going to have an infinite amount of x's to the left and to the right of it, infinitely. Or in simple English, it's going to go to the left and to the right forever. But your range is not all real numbers. Pause this video and figure out why your range is not all real numbers. See if you can explain it to yourself. Okay, it should be this simple. If you pause the video and had a shot at it, your range, how far does it go up and down? If it's all real numbers, that means it contains every positive and every negative y. Or in English, it's going to go up and down forever. The simple answer is it doesn't go up forever. It goes down forever, but it doesn't go up forever. It has a high point. So it goes from -2 on the y, and then it goes down forever. That's technically your range in English. It starts at -2 on the y, then it goes down forever. But we have to write it, whenever you're writing your domain and range, when there's a limit, you write it as an inequality. So you would say your range, which is y. Y is less than or equal to -2. There's your range. Because it starts at -2, then it's all the y's that are smaller than -2. So your domain is all real numbers. Your range is anything less than or equal to -2. Why is it equal to? Because it's a darkened circle. If it was an open circle, then it wouldn't be equal to. Okay, the next graph. All of these graphs are from the notes. This coordinate is -3, 1. This coordinate looks like it goes up to 0, 3. And this right here is 1, 2, 3, 4. 4, 0. Okay. What's your domain? Let's think about this in English first. Because if you look at the graph, at the explanation, it looks super, super weird and crazy. Let's think about what's your domain of this graph? Don't worry about the shape. Your domain is left and right. So how far does it go to the left and to the right? Don't worry if it goes up and down forever or whatever. Just what point does it start? What point does it end? Well, it looks like it starts on the left at -3. It starts from -3, and it goes all the way to 4. That's your domain. Okay. Now, the way you have to write this is an inequality. You're going to say this. X is greater than or equal to -3, so that means it's bigger than -3, but notice how it doesn't go on forever. It stops at 4. So x is less than or equal to 4. You write this as a compound inequality, looking like this. You would say, I'm going to combine both of these into one sentence. I'm going to say x is bigger than -3, so -3 is less than or equal to x. X is greater than or equal to -3, but notice how it's less than or equal to 4. This is called a compound inequality. Now let's try the range. How far up and down does it go? What's your highest point on the y? What's the lowest point? It looks like the highest point is 3. And it goes from 3 and it stops at the lowest point, which is 0. But we can't leave it like this. We have to write it as an inequality. So let's try to break it into 2 inequalities, starting at 3. We're going to say y is less than or equal to 3, because it's smaller than 3. 3 is my highest number, then it goes down. But it stops at 0, so it's bigger than 0, but it's smaller than 3. Y is greater than or equal to 0, but it's less than 3. Let's write this as a compound inequality like this. So I'm going to say 0 is less than or equal to y, or notice how I just switched this sign around, which means the same thing. Y is greater than or equal to 0, but it cannot exceed 3. 0 is less than or equal to y, which is less than or equal to 3. Or y is greater than or equal to 0, but y is also less than or equal to 3. This is your domain. This is your range. Notice your domain has the x. Your range in the statement has the y. Notice your range has the y. Your domain, if it's all real numbers, it's just all real numbers. But if it's in between, it's always x. Okay, now what I want you to do is look at the last one. Cover up the answer for the last one and see if you can figure this out. Cover up the answer. Don't look at the notes. I'm going to draw it right here. This coordinate looks like it's -4, 3, and this coordinate looks like it is 3, -3. And the graph starts here. It's going to go down to here. See if you can find your domain and range of this graph. All right, let's write this in English first. What's my domain? How far does it go left and right? Well, the smallest number on the x is -4. See? And it goes all the way. Don't worry about the shape that it goes down. It doesn't matter. It contains every x all the way to 3. We have to write this as a compound inequality. So we're going to say -4 is less than or equal to x, which is less than or equal to 3. There's something wrong with this statement that I just said. Notice this open circle. That means x cannot equal -4. It's bigger than -4 because it's to the right of -4, but it cannot equal once you get at -4. So it's -4 is less than or x, which is less than or equal to 3 because it's a closed circle. Now let's try the range. How far does it go up and down? Pause the video, see if you can do it without looking at the notes. All right, well, let's figure out how far up and down it goes. My biggest number is 3 that it starts at, and it goes down all the way to a -3. But let's write it as a compound inequality. So I know it is y is greater than or equal to -3. See, it's bigger than -3 because it goes up, up, up. Any y coordinate that's bigger than -3 will hit it all the way up into +3. But it can't equal +3. Why can't it equal? Well, let's look. 1, 2, 3. Notice when I go across, it's an open circle. Notice if I have here, let's say this is 2.9999999 right here. You sure it could hit right here. Let's say this is 2.98888888888. It hits the graph, but right when I get to +3, it cannot equal. So this is my domain. This is my range, and this is my domain.